Welcome back. Tonight we're going to talk about real numbers. We've already talked about rational numbers, integers, natural numbers, and now we're going to learn about irrational numbers. So before we can do that, we'll go ahead and review some of our information. Now, numbers, natural numbers, which are the counting numbers like 1, 2, 3, and 4. So if we look at the numbers that are to the right, we can see that 1 is a counting number. Now you can't count something that has 0 objects, and so 0 is not considered a natural number. So 1 is, you can't count -3 horses, so -3 won't be 1. And 4 will be natural numbers. If we look at our whole numbers are numbers like 0 is a whole number because it can be divided by 1. 1 because it's another whole number. And 4. So you notice the difference between whole numbers and natural numbers is that whole numbers include the number 0. Integers are natural counting numbers, which is 1 and 4, whole numbers, which include 0, and they include the positive or negative whole numbers. So 0 is a positive or negative whole number because it is a whole number. 1, 4, but also -3. -3 is also an integer because it is a negative whole number. Now, if you remember we talked about rational numbers, we remembered that rational numbers start with the first 5 letters is ratio. So a rational number is something that can be written as a fraction or a ratio. So if we look at the numbers to the right, we see that 3/4 is a number that can be written as a fraction or a ratio. 1 can be written as 1 over 1 or 4 over 4, so it can be written there. 0 can be 0 over 1. Pardon me. -3. So basically is what you can see is that it'll be the same as all of the integers, negative and positive whole numbers, and anything that can be written as a fraction or a ratio. So what does that leave out? Well, it leaves out those things like terminating decimals, which is like 3/4, which is 0.75, and it stops. Repeating decimals like 2/3, which is decimal 66666, and it keeps going. All those ones that are not rationals, we call irrationals. And we call it that because the prefix IR means not. So if we look at our value, 3/4 terminates, so it is a rational number. But pi is a number that goes on forever, 3.14159, and it has decimals that do not ever repeat. So pi is an irrational number. The square root of 13 is also an irrational number, because if we take our calculators and take the square root of 13, we see that it is 3.605551275, and it keeps going on, but it never repeats. We'll learn more about irrational numbers in the rest of this lesson. So, what are the characteristics of rational and irrational numbers? Rational numbers are basically numbers that can be put in the form of a ratio. Those include fractions, repeating decimals, and terminal decimals, in other words, decimals that end. Irrational numbers, not rational numbers, are numbers that cannot be put into the fractions. They are non-repeating decimals and they're non-ending decimals. So let's look at a few examples. -1. Well, if we use a calculator, -1 as a decimal is just -1. Since it is an integer, it is rational. 2 is a whole number, or actually even more specific, and it is a natural number, and so it is also a rational number. 1/4 is 0.25. That is a terminal or a terminated decimal, and so it also is rational. -3/8 is -0.375 or 375 thousandths. Since it terminates, it is also a rational number. 1 2/3 is 1 and 666666666, continuing on. That's what that little bar means, which means it is a continuing, a repeating decimal, which is a fact, a rational number. Let's look at some of these other ones. 1/7. Now, if I did 1/7 in my calculator, I would get 0.142857, 142857, 142857 that repeats. It has 6 numbers that repeat, but it does repeat, so it is a rational number. Pi was 3.14159, and it kept going on forever, and it did not repeat, so this is irrational. Let's look at these weird little ones, though. The square root. Now, the square root means what times itself will equal 25. Well, what times itself? If we're looking at the square root of 25, what times itself is 25? Well, the answer to that is 5. And since 5 is a natural number, it is rational. But what times itself is 20? Well, we know 5 times 5 is 25, and 4 times 4 is 16, and so this will lie somewhere between 4 and 5. If I use my calculator, I see that it's 4.47213595 something, and it continues on without repeating. So therefore, it is an irrational number. Let's look at the next one. 2 decimal, 10, 110, 1110, 111110, and it continues on there. Well, obviously, the pattern does not completely repeat. There's no repeating, and it does not end. And so, therefore, it is irrational. If we can give them to decimal equivalents, then we should be able to put them on a number line. So what I want you to do on your own is to place them on the number line. Then I want you to circle the irrational numbers and underline the rational numbers on your number line. Good luck.